Thank you. So not E, the opposite. So event E was 1 minus probability of whatever event you have. We need to use some letters that they use in this text. So if I was to get exercise 14 from this position, then I could go with 1 minus probability of E, which is out of 3,000 to take. So when E was here, right? 840. So if I enter this in a calculator, that'd be getting the same thing, but using a bit different approach. So you could just subtract and see what is going to happen in that case. So if I divide 3,000, notice the answer is going to be exactly the same, which is not surprising, right? The answer in mathematics classes is always the same. So we have problem that could be done various ways, and I don't mind if you take any approach you like. So you don't have to do it exactly the way that I solve it. You can always find your own method. And as long as you get the correct answer, it's absolutely fine. And it's very good if you do it on your own. So let me flip the page and notice there are more exercises in this section. So today we'll keep working on this next page. I guess we'll go up to problem number 48. So I guess it will be plenty. So I don't want to be stuck with this forever. So let me do some exercises on the next page, and I hope we'll feel more and more comfortable about the probability story. So I'm going to be taking the problem like 17 and keep going. So let's try exercise 17. That says 2 or 3. So what are they talking about? Well, you're dealing with a deck of cards. So in exercise number 17, they want to know probability that you will get 2 or 3 when you pull a card from a deck of playing cards. And on the previous page, let me go back, they actually very nicely described a deck of cards here. Did they? Actually, they just have various types of hand. So let me see where they have a deck of cards, so I don't have to draw it. I think they had very nice picture of it. I was so impressed. So let me find it so we can all take a look at it. Let's see. Oh, here it is. So we have a deck of playing cards, and it's shown here on the left side of this beautiful picture. So you can see that there are 4 suits, right? And there are 13 cards in a suit that composes 52 cards total. So we'll select 1 card from total of 52. So I put the total as usual in denominator. And now they care about pulling either 2 or 3, like in the first suit diamonds here, there are 2 cards. Also, there will be 2 cards in the other suit, in hearts or in the spades, as well as in the clubs, right? So how many cards are we interested in? Well, looks like that'd be 8 from 52. So I try to mark them with a check mark. So it's good to look at this picture for a while to realize what the deck of cards has if you haven't ever played cards, you can look at those 52 cards. And then I will put this in calculator. I will divide 8 by 52. I know you can reduce this and get something like 2/13, but we could just use a calculator and that'd be good enough. So the answer is 0.1538. So in the future, I would prefer to use a calculator for the answers, because sometimes you get a fraction with not very convenient numerators and denominators, just like we did here. So you don't want to start to cancel all that because it will take you a while. So the idea is just use calculator, put your fraction in it, and have calculator give you the answer. So that'd be much more comfortable and convenient, right? So let's see what else is here. So they have a whole bunch of exercises that want you to pull one card from that deck of playing cards, and they seem to be pretty much all of the similar type. So I can try one more here, like exercise 24. Looks like it's a little bit of a story that talks about a political discussion group that has 30 Republicans, 25 Democrats, 8 independents, and 4 members of Green Party. So looks like we have a whole bunch of people here. 30 Republicans, 25. So I better write it all down, right? Democrats and 8 independents. 8 independents. And finally, 4 members of Green Party. Okay. So it's good to realize that we don't have just 2 parties in the United States. There are lots of them, but I guess most popular are Democrats and Republicans, but there are also independents and there are other parties also. But I guess that's an interesting fact. So the question is, find the probability when you looks like select one person from this group, find the probability that this is either independent or green. So I need to write this down so I can put I or G here, right? And I need to see what would be the total. How many people are we dealing with in here? So it looks like it'll be 55 and 12, 70, 67, right? 55 and 12 looks like it's 67. And for, that's my total. And for numerator, I need to use either one of those 8 or 4 means add them together, or means plus. So I'm gonna divide 12 by 67. That looks like we keep on producing our favorite little fractions, and that's all we really are after in this section. So whatever the result is, I just write it down. It'd be 0.179 ... right? Okay. So put a few decimals and then ... and that should be good enough. So probabilities are fractions. It's not surprising. And we kept using this idea throughout this entire chapter so far, produced all kinds of fractions. So I say that you probably could go up to problem number 48, and that'd be good enough for this section. So let me try some problems here at the section end. Looks like we have a table again. So the table that talks about educational attainment. So this little table that has problems from 41 and on. Actually, do it up to problem 46, because I don't want to talk about odds. That's something that usually not being covered. So we'll go up to problem number 46 in this section. So try 41. I think that'd be nice exercise. So we here dealing with a question about finding probability, as usual. So in exercise 41, it says, what's the probability that a person has not completed 4 years or more of the college? So I need to carefully look at the table and notice that we have a total of 174 people considered. So that'd be my denominator, because we put that grand total always in denominator, right? So what about numerator? Well, looks like we have 4 years college or more, which is here, right? And the question to exercise 41 says, what's the probability that person has not completed 4 years of college? Notice that the previous columns are talking about less than 4 years, but that's a high school, and then 4 years of high school only, so those have nothing to do with the college. Some college, but less than 4 years, that's also fits description. So the only column that we don't use will be this 45 people, looks like, right, that completed 4 years of college. So how can I do that exercise? Well, I can utilize the previous idea, the complement or not, or 1 minus, right? 45 out of 174. So I just did the complement. So from 1, I subtracted the probability that person did complete 4 years of college, because what I need to find is the chances that the person is on the opposite side, has not completed those 4 years. So you just go with the complement then. And again, it's one of the ways, because you could have calculated this directly if you wanted. I guess I'm not going to do problem 2 ways every time, because what's the point? These exercises could be done 1 way or the other, but you don't have to do it both ways, and using complement and then using direct calculation like I did before. So I put few digits and ... and looks like that'd be good enough. So table and the complements in here, and looks like that's pretty much same story as we already saw previous time. We also did a problem for a quiz. So the message is, it's not any different with the stuff that we already saw. So just more similar exercises. So that's why I would like to move on to the next section, which continues talking about finding those little probabilities. So you don't have to worry about this page, because there's just more and more exercises. So I'll just go to 11.7. That adds more to the story. So instead of doing selection of only one element, now we start to select more. So for example, here's the exercise that talks about getting a coin that is flipped twice. So they say first flip, you could get either head or a tail, right? And then you flip it again, and again you can get either a head or a tail. And it wouldn't matter if your first result was a head, you still get either head or tail. Or on the first flip you got tail, it's still going to be either head or tail. And they actually listed 4 possibilities right here, the ones that you can see out of my little tree diagram. So you can see that you could go with 2 heads, and that's exactly the first, or you could get a head and tail, so that'd be the second, right, like that, and so forth. So there are 4 possibilities. So since 4 is total, our denominator will be 4, and numerator will be the number of selections that we're trying to calculate our probability of. And what we're trying is to get both heads. It looks like there is only one, right? Only one possibility when you have both heads out of these 4. So the answer is 1/4. So I think that's pretty straightforward. But the reason they talk about this exercise is to actually show you that there is a different way to get that probability calculated. And I think that's very interesting to notice, that you could split this into finding probability of head, and again, when you flip your coin second time, to get a probability of head. In other words, what they're saying is get probability of heads and again probability to get head. And when you flip your coin, the probability of heads will be only 1 out of 2 possibilities when you flip your coin once. So you can get either head or tail. There are 2 choices. And you're interested only in the head. So it's 1 out of 2 choices. Now, when you do this experiment once again and trying to see what be chances to get a head once again, well, you will have again 1 out of 2 choices. And notice that when you multiply 1/2 by 1/2, you will get exactly the same result, 1/4. I think we already saw something like that before, right? So this is multiplication rule that works when you repeat your experiment. So I guess I'd like to look at some exercises and start to multiply. Basically, all they care about is to multiply when you repeat your experiment again and again. Then you just multiply those and get your answer. So I want to just start with this section today. So look only at this page here, 11.7 section. So let's see how you can do problem like exercise number 4. So we going to get 2 times our experiment. So it looks like you have a spinner, and in exercise 4, they say, what's the probability to get red and then again red? Well, looks like I'm gonna get a probability of red, and means times, multiplied by another probability of red, which is gonna be exactly the same thing in both cases, right? And looks like we have 3 reds out of how many? 6? Let me say, at least this is 1/2. Okay. And then when you rotate it once again, it'd be the same again, 3 out of 6. So if you reduce this, you get a half multiplied by another half, and this will be 1/4, just like that. So you multiply these probabilities because you have 1, and then again, and means times another. So another time you repeat the same exact experiment. Please notice that solving problem this way will be definitely much faster. If you decided to produce this tree diagram, it's going to be quite a mess because it'd be actually 36 possibilities total in denominator. And that's why this formula, which is calling for multiplying, I think is pretty nice and straightforward to use. So let me try another one. How about exercise 11 here? I just want to start this section today. So the new part about this section is that now we repeat experiment again. So before we just did one time, either spin or roll the die, but now we repeat it. And the question is, find the probability of rolling a 2 on the first time and 3 on the second time. Well, looks like for exercise number 11, I'm gonna multiply probability of 2 by probability of 3, just like that. Okay. And remember how this die looked like? We have these little selections like 1, 2, 3, 4, 5, 6, right? There are 6 choices here. And when you roll in your die once, out of the 6, well, you can get just about anything. So if you're interested about 2, there's only one such a selection from my 6 possibilities, right? And then when you repeat your experiment and interested in getting a 3, so there is also only 1 3 out of 6 possibilities. So you can multiply these 2 fractions. You multiply numerators, you get 1, right? And denominator 6 times 6 is 36. So looks like we got the answer. So multiplying is a goal for this. So maybe you can try to enjoy this multiplication rule and do exercise number 2 here for a quiz for today. So I will be stopping the recording.